Hello, this is section 9.4, Solving Equations in Quadratic Form. Part 1, Solve Equations in Quadratic Form. Suppose we want to solve the equation x to the fourth minus 4x squared minus 5 equals 0, which isn't a quadratic equation because it's to the fourth power. Notice we can write the left-hand side of the equation as x squared minus 4x squared to the first power minus 5. Then if we let u equals x squared, then the left-hand side becomes u squared minus 4u to the first power minus 5, which we can solve using our methods for solving quadratic equations, because now it is a quadratic equation with the variable u. Example 1. Solve the following equations by using a substitution like u equals x squared in one of our methods to solve quadratic equations. Note, our final answers should be of the form x equals, so after solving the quadratic equation in terms of u, we must put the equation back in terms of x and solve using other methods. Part A, x to the fourth minus 4x squared minus 5 equals 0. So we already know the u substitution we use here is u equals x squared. So then it became u squared minus 4u minus 5 is equal to 0. So remember, we have 4 ways to solve quadratic equations. I always recommend you try factoring first because it's the quickest if it works. In this case, it does. We get u minus 5 times u plus 1 after a little bit of guess and check is equal to 0. So we get u minus 5 equals 0, or u plus 1 equals 0. Add 5 to both sides, we get u is equal to 5. Subtract 1 from both sides, we get u is equal to negative 1. But again, these aren't our answers because we need to solve for x, but since u is equal to x squared, this implies x squared is equal to 5, or x squared is equal to negative 1. If we take the square root of both sides now, we get the absolute value of x is equal to the square root of 5, or the absolute value of x is equal to I, which means x equals square root of 5, or x equals negative square root of 5, or x equals I, or x equals negative I. So we got 4 solutions for this one equation. Part B, x to the fourth minus 11x squared plus 28 equals 0. So again, I'm going to notice that x to the fourth is the same thing as x squared squared. 11x squared to the first power plus 28 equal to 0. So I'm going to let u equal x squared again. So we get u squared minus 11u plus 28 is equal to 0. That factors as u minus 7 times u minus 4 equal to 0. So we get u minus 7 equal to 0, or u minus 4 equal to 0. So we get u equal to 7 after adding 7 to both sides, or we get u equal to 4 after adding 4 to both sides. Now we have to put our x variable back in, so this means x squared equals 7, or x squared equals 4. Take the square root of both sides. We get the absolute value of x is equal to the square root of 7, or the absolute value of x is equal to 2. So we get x equals the square root of 7, x equals the negative square root of 7, x equals 2, or x equals negative 2. Again, for 4 solutions to this equation. Part C, we have the quantity x minus 2 squared plus 7 times the quantity of x minus 2 to the first power plus 12 is equal to 0. So here I am going to let u equal x minus 2. Technically, we don't have to do a u substitution here, but it is a lot quicker than distributing everything out. So this becomes u squared plus 7u plus 12 is equal to 0. Which factors is u plus 3 times u plus 4 equal to 0? So u plus 3 equals 0, or u plus 4 equal to 0. So we get u equal to negative 3, or u is equal to negative 4. But again, u is x minus 2, so this means x minus 2 equals negative 3, or x minus 2 equals negative 4. And add 2 to both sides of both equations. We get x equals negative 1, or x equals negative 2. Now part D, what are we going to do here? Well, the first thing I recommend is rewriting everything in exponential form. So the square root of x is the same thing as x to the 1/2 power plus 2 equal to 0. Now, in the previous 3 examples, the u substitution wasn't too hard to see, but when you're looking for the u substitution, you're looking for what thing squared is equal to a second thing. That is a little vague, I give you. Well, here, what I can do is x to the 1/2 power squared is equal to x. And then minus 3x to the 1/2 power to the first power plus 2 is equal to 0. So in other words, this exponent of 1 was double the exponent of 1/2. So that's what you're looking for to determine if you can use a u substitution. One of the exponents is double the other. So now I can see I'm going to let u equal x to the 1/2 power. So we get u squared minus 3u plus 2 is equal to 0, which factors is u minus 2 times u minus 1 equal to 0. We get u minus 2 equals 0, or u minus 1 equal to 0. Add 2 to both sides, add 1 to both sides, and we get u equal to 2, or u is equal to 1. Now plugging our x variable back in, we get x to the 1/2 power equals 2, or x to the 1/2 power equals 1. To get rid of the half power, I'm going to square both sides, because when you do a power to a power, you multiply, and 1/2 times 2 is 1. So we get x equal to 4, or x is equal to 1. Now, remember, whenever you have an equation with a square root in it, you should check your answers for extraneous solutions. If you check the number 4 and the number 1, both of them will work. X to the 2/3 minus 2x to the 1/3 minus 24 equal to 0. Here I'm hoping you realize x to the 2/3 is just the same thing as x to the 1/3 squared, because 2/3 is double 1/3. So I'm going to let u equal x to the 1/3 here. So we get u squared minus 2u minus 24 is equal to 0, which factors is u minus 6 times u plus 4 is equal to 0. So we get u minus 6 equals 0, or u plus 4 equal to 0. So u is equal to 6, u is equal to negative 4. Plug the x back in, we get x to the 1/3 equals 6, or x to the 1/3 equals negative 4. To solve for x, raise both sides of both equations to the third power. So we get x equals 216, or x equals negative 64. Part F, 3x to the negative 2 minus 7x to the negative 1 plus 2 equals 0. Again, x to the negative 2 is just the same thing as x to the negative 1 squared. So I see that my u substitution should be u equal to x to the negative 1. So we get 3u squared minus 7u plus 2 is equal to 0. To factor this one, I'm actually going to use the asterisk method. A times c is 6, b is negative 7, and then we get 3u, 3u. What two numbers multiply to 6 and add up to negative 7? Well, that's negative 6 and negative 1. This one reduces to u over negative 2. So then it factors as u minus 2 times 3u minus 1 is equal to 0. So we get u minus 2 equal to 0, or 3u minus 1 equal to 0. Add 2, we get u equal to 2. Add 1, 3u equals 1. Divide by 3, u is equal to 1/3. Plugging x back in, that means x to the negative 1 power equals 2, or x to the negative 1 power equals 1/3. To get rid of the negative 1 power, you actually raise both sides to the negative 1 power. And remember, when you raise a number to a negative power, it means to flip it. So we get x equals 1/2, or x is equal to 3 over 1, or just 3. Now, just like with square roots, we have to realize here, x to the negative 1 is the same thing as 1 over x. So technically, even though part F didn't have fractions written, the x to the negative 1 and x to the negative 2 are hidden fractions. So that means you have to check for extraneous solutions. So you should plug both of these in, make sure they work, and they do. And that is the end of section 9.4.